Students, so coming to the next topic, that is the fragmentation. So this is one of the important concept in main memory. So you have to know the concept of fragmentation. So how the data is storing in main memory, how the data is removed from the main memory and swapping to the secondary memory, again it coming back. Whenever it is coming back, is there is a space in main memory or not? So that everything will be depends upon the fragmentation. So first let me explain what is a fragmentation. It is a process, suppose a process or loaded and removed. So a process is loaded in main memory and removed from memory. Again you removed from memory. The free space, whatever that is present in the main memory, the free memory space is broken into little pieces. Okay, first let me, a process, suppose any process that is there, that process wants or loaded in main memory. Suppose it is loaded in main memory, process P1, and removed from main memory. It's just suppose this is a process 1, P1, and removed from main memory and placed in the secondary memory. So whenever it sends to that secondary memory, this space becomes free space. So the space in the main memory becomes free space. So this free space is broken into pieces. So whenever it sends the process, it broken the free space into pieces, small pieces. After some time, that process, whatever we send to the removed from the main memory, that process cannot be allocated to memory. It cannot be allocated to memory because of small size. Because of small size. So and also it and memory block remains unused. And here, and the memory block, whatever it is present, remains unused. This problem is called fragmentation. This problem is called fragmentation. So let me explain clearly with a simple example I'll take. Suppose this is a main memory. A main memory is holding the process P1. Okay. So a process are loaded in main memory and removed from main memory and stored into secondary memory. So after storing in the secondary memory, this is stage 1. So next, this is a main memory and this is a secondary memory. So here the process P1 is stored, and whatever the process that is removed from main memory is becomes free space. This is a free space because I moved the process P1 to secondary memory. So this becomes the free space. So this free space will be broken down into small pieces. Whenever the data is moved to the another, so this free space becomes broken into smaller pieces. Suppose this is 4 MB. Okay, this 4 will be divided into 2 and 2, like this. 2 megabytes and 2 megabytes. And this is here, this P1 is there, main memory and secondary memory. Suppose after some time this process wants to again come back to main memory. This is swapping technique. So the P1 again wants to come back to main memory. But here already the memory that is there previous, that will be divided into smaller pieces. So it cannot be allocated to memory because of small size. And memory block remains unused. So because this is 4M, this 4M process cannot be moved to this, cannot store in this 2M and 2M. Because this is partitioned. So this process cannot come back to main memory and this memory remains unused. Memory remains unused because we are not storing anything here. because this is 2M and 2M. So this process cannot come back to main memory because it is already divided into smaller pieces. So it cannot fit in this memory block. So this memory blocks remains unused. This problem you call it as a fragmentation. The process that cannot fit into that memory block, that problem you call it as a fragmentation. First, it sends a process to swap it to the secondary memory and makes the memory free. So whenever the memory is free here, it divided into small pieces, little pieces. So again the process wants to come back to main memory. We want to swap into main memory, but the memory block is already, it is small in size. So the memory block remains unused. This problem you call it as fragmentation. So this fragmentation is divided into two. One is external fragmentation and another is internal fragmentation. So what is an external fragmentation? External fragmentation means the total memory, whatever it is present in main memory, the total memory space is enough to satisfy a request or recite a process. First let me write, recite a process in it, but it is not contiguous, so it cannot be used. What it means? So the external fragmentation here is saying the total memory space is enough to satisfy a request or recites a process in it, but it is not contiguous. So here it is a memory is there. Okay, a total memory space is enough to satisfy a request. So there is some a process is there. A process wants to come back to this main memory P1. So there is an enough space is there. So enough space is satisfy a request or recites a process in it, but it is not a contiguous. It is not present contiguously because it is divided into two like that. So means the 4M can be stored in 1M here, 2M here, again 1M here. It is not in a contiguous memory location. So it is some dynamic approach is there. Dynamic, clearly you can set the program. You can store the process. So this type of problem you call it as external fragmentation. The total memory space is enough to satisfy. So it is enough. There is a space, the total memory space, there is a space. But whatever the request you are doing and whatever the process you want to store in this main memory, it can fit, but it is not in contiguous memory location. Means the data here, it is a fixed or dynamic, whatever it may be, it is fixed or dynamic, but it is but it is not contiguous. Not storing the data in a static or in dynamic way. It is not contiguous. So it cannot be unused. So whenever that is not is unused, then you call it as external fragmentation. Now coming to the internal fragmentation. In the internal fragmentation, memory block assigned to a process, is bigger. So whatever the memory block assigned to a process is bigger, and some portion of memory is left unused, as it cannot be used by another process. So a fragmentation can cause waste of memory, and compaction technique can be used to create more free space out of fragmented memory. So what they are saying that internal memory means here a memory block assigned to a process. So this is a memory block So here suppose the process P1 is 4 MB, 4M, and process P2 is 2M, like that. So a memory block assigned to a process, let's take this is 6M, 4M, 6M. A memory block assigned to a process is bigger. So this is 5M. The space here for the process is 5M allotted, and this is 8M, like that. A memory block assigned to a process is bigger. So here we are assigning a process partition that is bigger. Some portion of memory is left unused as it cannot be used by another process. What it means? So here they are saying I can store here 4M, but 1M is becoming waste. So this 1M I cannot use for the next process because next process is 6M. The 6M cannot fit into this 1M. So I have to use another partition, and again here 2M is wasted. So this wastage internal in the inside internal memory, main memory, the wastage of space, you call it as internal fragmentation. A memory block assigned to a process is bigger, but some portion, so already whatever the assigned block is bigger than the process whatever we are sending. So some portion of memory is left unused as it cannot be used by another process. So this 1M cannot be used by another process, and this 2M cannot be used by another process. Suppose P3 is again suppose it is 3M. 3M means it has somewhat it's stored in here, like that. Okay, suppose this is also 4M, it can here 3M is stored, and suppose this is a 4M, again 1M will be wasted. So this is about the internal fragmentation. So to overcome this fragmentation, the fragmentation memory can be compact, means you can shuffle fragmented memory. Before compaction it looked like this. Let me write that. So this is the fragmentation memory. Fragmented memory before compaction. Compaction means shuffle. So what we are doing, so this is suppose a memory, the block, this completely is a memory. So this is unused, and here another block, and this is unused, and this is some block, and this is another block, and this is unused, and again small block. So this is the blocks where the process can store, and this is the unused area. So after memory after compaction, memory after compaction means the shuffle, how it look like. So whatever the unused area is there, that will be moved to the last. So this is one process, next process, next process, and this is completely unused. Means we are just combining, we are shuffling all the unused partitions to make it as a one big partition. So that suppose this is 1M and 2M and 2M. So total 5M is there, 5M space. So this is 5M. So this 5M can be occupied by another process. So P1, P2, P3, P4, P5. Suppose P6 is 4M, so it can fit in this 5M. So the unused partitions can be, the memory space is shifted to the last, means we are shuffling here. So this is you call it as a compaction. Fragmented memory will be compacted, shuffled. The external fragmentation can be reduced by compaction or shuffled free memory together in one large block. So this can be, the external fragmentation can be reduced with the help of this shuffling. Let me write that point. External fragmentation can be reduced by compaction or shuffle free memory together in one large block. So this is one of the technique to make the external fragmentation reduced. And internal fragmentation can be reduced. Let me write that point also. Internal fragmentation can be reduced by effectively assigning the smallest partition. So whatever the smallest partitions is there, assigning the smallest partitions but large enough for the process, So this is about the fragmentation. So the fragmentations is a two type, internal fragmentation and external fragmentation. So these can be reduced with the help of this technique. Thank you.